Hi, this is Dr. Goldstein, and today I'll be talking about unit circle trigonometry. So to begin with, let's remember that the unit circle is given by the equation x squared plus y squared equals 1. So for any point x comma y on the circle, we know that when we take the x coordinate squared plus the y coordinate squared, we get 1. And one of the results of this is that any line that we take from the origin to a point on the unit circle has length 1. Okay, now what we've talked about in terms of trigonometry is if I take an angle and I construct a right triangle, for example, this right triangle here, then I can define sine, cosine, etc. of this angle in terms of the opposite side of the triangle, so the opposite side of the triangle, and the adjacent side of the triangle, and the hypotenuse. And what we see is that if our triangle lies on the unit circle, the hypotenuse is always going to have length 1, and also the adjacent side has length x, because the length of that side gives us the x coordinate of this point, and the opposite side is going to have length y. So on the one hand, when we define, for example, sine of theta, in terms of our right triangle definitions, we have the opposite side divided by the hypotenuse, and on the other hand, if we use the point x comma y, we end up with y over 1, or just y. And likewise, if we look at cosine of theta, from our right triangle definition, we have adjacent over hypotenuse, and that gives us x over 1, or just x. So what we do with unit circle trigonometry is for any angle theta, so let's pick another angle. Let's say our angle goes right here. So now this is a different theta. We look at the terminal edge of that angle, and we look at the point where it intersects the unit circle. And we can look at the x coordinate and the y coordinate of this point, and what we say is that the x coordinate is cosine of theta, and the y coordinate is sine of theta. So again, we define the cosine of theta to be the x coordinate of this point, and we define sine of this angle theta to be the y coordinate of this point. So let's see what this does in terms of the other trigonometric functions. So tangent of an angle, remember originally this would be the opposite over adjacent, and so the tangent of an angle is going to be the y coordinate divided by the x coordinate. Cosecant of theta, which is 1 over sine theta, is going to be 1 over the y coordinate. Secant of theta is 1 over cosine theta, which is 1 over the x coordinate. And cotangent of theta, which is 1 over tangent of theta, is the x coordinate divided by the y coordinate. So let's see how this works in terms of calculating sine, cosine, etc. of an arbitrary point that is on the unit circle. So for example, we're going to calculate sine and cosine for angles of 0, pi over 2, pi, and 3 pi over 2. So if we look at an angle of 0, we know that we are right over here on the positive x-axis, and so the point that we get that's on the unit circle is the point 1, 0. So remember, we defined sine of an angle to be the y-coordinate, and so sine of 0 is 0, the y-coordinate of that point, and cosine of 0 is the x-coordinate, which is 1. So again, this 0, this is the y-coordinate, and the 1 is the x-coordinate. Likewise, if we look at an angle of pi over 2, so here's pi over 2 right up here. This is pi over 2. And we look at the point that's on the unit circle. Well, this is the point 0, 1. And so if we look at sine of pi over 2, we want the y-coordinate of that point. So sine of pi over 2 is 1, and cosine of pi over 2 is the x-coordinate. So cosine of pi over 2 is 0. So again, this is the y-coordinate and the x-coordinate. Now, if we look at the other two angles, if we look at pi, pi is over here, and the point that we get on the unit circle is -1, 0. And if we look at 3 pi over 2, that is down here. There's 3 pi over 2. The point on the unit circle is then 0, -1. And so if we calculate sine of pi, we get the y-coordinate 0. So again, this is our y-coordinate. And if we calculate cosine of pi, we get -1. And that's the x-coordinate. When we calculate sine of 3 pi over 2, we have -1, and that's the y-coordinate of that point at angle 3 pi over 2 on the unit circle. And cosine of 3 pi over 2 is then 0. So this is sine and cosine for any angle that lies on the unit axis, including any multiples of these angles. So 2 pi, 4 pi over 2, 7 pi over 2, all of these. This is how you calculate sine and cosine of those angles. So let's look at a little bit of a harder angle. Let's look at negative pi over 4. So negative pi over 4 is going to be down here. So here is negative pi over 4. And what we want to remember now is our 45, 45, 90 triangle. So this is, let me draw that a little bit more clearly. This is minus pi over 4. If that angle is pi over 4, then the other angle down here is also pi over 4. And so we know that the sides of this triangle are root 2 over 2, root 2 over 2, root 2 over 2, and 1. So the coordinates of this point on the unit circle, the x-coordinate is root 2 over 2, and the y-coordinate, notice that we've gone down in the y direction, so the y-coordinate is minus root 2 over 2. So if we go to calculate sine, cosine, and tangent, remember that sine of an angle is going to be the y-coordinate. So sine of minus pi over 4 is negative root 2 over 2. Cosine of minus pi over 4 is the x-coordinate, so is root 2 over 2. And remember, tangent of an angle is sine over cosine. It is the y-coordinate over the x-coordinate. So we have minus root 2 over 2 divided by root 2 over 2, which is just minus 1. So again, when we're looking at sine, we want the y-coordinate. When we look at cosine, we want the x-coordinate. And tangent, you can either think of this as sine over cosine, or you can think of this as the y-coordinate divided by the x-coordinate. Okay, let's do one more example of this. Oh, before we move on, actually, I just want to mention that this triangle that we have right here is often called a reference triangle. Reference triangle. And it actually doesn't matter how you draw it in relation to the axes, as long as you label the sides correctly and you end up with the correct coordinates of the point that's on the circle. So for example, if I drew this triangle over here against the y-axis instead of the x-axis, I would still get the correct answer, because the sides of this triangle would still be root 2 over 2 and root 2 over 2. So I can draw my reference triangle wherever I like, really, as long as the coordinates of the point end up being correct. Okay, let's look at one more example. We are going to calculate sine, cosine, and tangent for an angle of 4 pi over 3. So first off, let's take our circle, and what I'm going to do is actually break it up into pi over 3s. So I have 0 is right here, 1 pi over 3, 2 pi over 3. Remember, pi is the same as 3 pi over 3. And so 4 pi over 3 is going to be right down here. This is 4 pi over 3. So now, again, I can put my reference triangle wherever I like. I'm going to put it against the x-axis. And now I know that this angle right here has a measure of pi over 3. If I just look at my triangle, that angle there is going to be pi over 3, which is 60 degrees. And so the side opposite that has length root 3 over 2. Now, this other angle over here is pi over 6, and so the side opposite that has length 1/2. Now, what I really care about is the coordinates of this point. And notice that I'm moving 1/2 in the negative x direction, so the x-coordinate of this point is minus 1/2, and I'm also moving in the negative y direction to get to this point. So the y-coordinate of this point is minus root 3 over 2. Okay, so now when I go to calculate sine of this angle, I want the y-coordinate of that point, and so it's going to be minus root 3 over 2. Again, for sine, I'm looking at the y-coordinate. For cosine, I'm looking at the x-coordinate, so cosine of this angle is going to be minus 1/2. So again, this is the x-coordinate. And tangent of this angle, again, I can think of it as sine over cosine, or I can think of it as the y-coordinate over the x-coordinate. So this is going to be minus root 3 over 2 divided by minus 1/2. So again, this is y over x. Now this we can simplify. I have minus root 3 over 2 times the reciprocal, minus 2 over 1. My 2's cancel, and I have 2 negatives. So tangent of this angle ends up being positive square root of 3. So all in all, when you are calculating sine, cosine, tangent, etc., for any standard angle, for any angle that's a multiple of pi over 2 or pi over 3 or pi over 6, what you want to do is sketch that angle on the unit circle, label the lengths of the sides of an appropriate reference triangle, and use the coordinates of the point where the terminal angle intersects the unit circle in order to calculate sine, cosine, tangent, etc.